We have a lot of things going on kind of simultaneously right now. We are in the process of creating an inference portfolio. And at this point, you should have been able to do 1, 2, 3, and today we're going to do 5. Let me just make sure that I have my inference, I'm speaking correctly, so let me get my inference portfolio cover sheet just to make sure, but I'm pretty sure I'm right. So 1, 2, 3, and then we're going to do 5 today. We've also done 6, 7, and 10, and we're going to do, we're going to do number 9 today, okay? So we will have done almost all of 1 through 10. After spring break, we will do 4 and 8, which will mean that on April 10th, well, I said April 8th, right, was the due date, you are going to turn in numbers 1 through 10. Okay, that's what's going to be due on April 8th for the inference portfolio, just so you know. The chi-squared tests, which are part of the portfolio, are just not going to be turned in at that day, on that date. Okay, they'll be turned in separately or later. Since you have 10 things to submit and it's worth 100 points, which ones, what do you think each one's going to be worth? 10 points, okay? So kind of keep that in the back of your mind when you're doing this, that each sheet that you're doing is going to count 10 points. Fair enough? On April 8th, and it's going to be 1 through 10 on the inference portfolio. Any questions about that? We're good? Okay. The next thing that we're currently working on is our SAT investigative task. It's going to be in 2 parts. Today you're turning in parts 1 and 2, or numbers 1 and 2. I'm calling it part 1. Part 2 is numbers 3 and 4. After today, so you're turning this in today, so 1 and 2 are due today. The second part I'm going to assign you in about 15 minutes or so. You're going to be able to do part 3 today, and then number 4 after spring break. Okay? Part 2, so this is part 1, this is part 2. Part 2 will be due the Thursday after spring break. Okay? So it won't be due, you're going to get assigned today, it won't be due the day you get back, the first class after spring break, it'll be due the second class after spring break. But you're going to have to do some of it in class today. I'm going to give you some time to work on number 3. Okay? Those are some kind of things that are lurking in the background, some assignments that we should be working on and continue to work on. I really do want you to enjoy spring break, and I'm not going to give you a whole lot of work other than this and a couple problems from the textbook, 4 to be exact, on what we're going to do today. Because I really think that you should take the time to sleep, heal, okay, do whatever. So I'm not going to give you massive amounts of work to do. We've been working on these things all along, so it's nothing new, okay? All right, so let's jump into the new stuff for today. So this is what we're going to be talking about. We're talking about a matched pairs t-test, and that's the name of the test, and that's what we're going to call it. It is not chapter 25. That's from the old book. We have new books. But it is called a matched pairs t-test, so that is important to know. If you look on your calculator, you will never see something called matched pairs t-test. It's actually not a test that's listed. And that's because we actually use a regular t-test on the calculator to do it. But we'll talk about that in a minute. If you notice on the SAT investigative task that we have done, we used which variable? Well, there was 3 variables, if I remember. There was the math score, the verbal score, and what else? Gender, okay? We will eventually use all 3 of those variables, but for us and our purposes, what variable did we use? The math score. What kind of variable is that? Qualitative or quantitative? Which one? Quantitative. It's measurable. And that's what we're going to do for a t-test. You need measurable data. I can find the mean score. Okay? Same for the verbal score. We can find the mean verbal score. When it comes to the categorical or qualitative variable of gender, that's a whole different ball of wax, and we're going to talk about how that comes into play, and it actually deals with part 4 of the SAT investigative task, okay? So we'll talk about that after spring break. But for us, we're going to look at something called a matched pairs t-test, or paired data. Can someone explain to me, if I look at, someone have their, look at Jenny's highlighted problems, or highlighted data. Okay, these data, okay? The highlighted data. Why is this matched? How is this matched? What do I mean when I say matched? Each line that's highlighted, Matt. Right, so each person is one highlighted row. Would you agree? So each person is what you're matching by. The person's verbal score and the same person's math score. So we are matching by person. Sometimes we can match in other ways. Remember back when we did experimental design back in like November, October-ish, we talked about a before and after design in experiments, where we'd measure something, we'd give them a treatment, and then we'd measure them again. Do you remember that? I think I used weight loss as an example. We get on the scale, we go through some weight loss program, we get back on the scale and see if there was a difference and if the treatment worked. That before and after design is also matched. It's matched by person. The same person is weighed before and is weighed after. You can look at plants, for example. You can measure their height or give some kind of measurement on a plant, give them some sort of treatment, fertilizer, measure them later, before and after. That's a very common matched pairs t-test. And that's what we're going to be looking at today. Okay? So, paired data are often from an experiment, like I just said. An example, a concrete example for us, though, is this SAT investigative task that we're doing, because that really is something that you kind of got your teeth into already. The problem with a matched pairs t-test is that the condition of independence is not, it doesn't hold. Why? Not because of that necessarily, but think about this maybe. Corinne's verbal SAT score, is it independent from Corinne's math SAT score? No. Usually good students perform higher on both, right? As opposed to poorly, not such a strong student. Except for your Mrs. Macker, and there's a 200-point difference between the two, because I'm really good at math, but not so great at verbal. That was my discrepancy there. Turned out okay in the middle, but, whatever. But usually, we could say that they're not independent. Okay, they're paired. They're paired for a reason. So we're going to treat them a little bit differently. Okay? Here are just some other examples of paired data. You probably, if you look at any kind of the ologies, a lot of the science experiments that are done, twins are a common thing that they want to use because they're genetically the same. So they want to say, okay, one twin goes in this treatment group, another one goes in this one, and we can measure. Two subjects that are alike in some kind of way, whether it be age or gender or whatever, we can put them in one group and another group. We can pair them in some kind of way. Okay? Now, the procedure, there's a lot of words here, so I'm just going to kind of highlight what's important. The procedure for a matched pairs t-test is going to be almost exactly the same for a regular t-test, except for how many kinds of data do I have in the beginning. I have a verbal score and I have a math score. So how many lists do I have? 2. And I got to figure out a way to make those 2 lists become one list, because I know how to find the mean of one list. So what we're going to actually do is compute a third list, and that will be the differences between the pairs. So when we do a matched pairs t-test, we're actually going to find the mean of the differences. And we're actually going to find the standard deviation of the differences. And this is the notation that I want you to use. That little subscript D means differences. Okay, and that's commonly accepted, widely accepted in the AP Stats community. They know what that means. So anywhere that we use an X bar before or an S before, now we're going to use that difference column. Okay? So it actually takes both lists, or two samples, and makes it one. So it actually moves it from a two sample case to a one sample case, which is kind of nice because once we have one sample, we've done it, we know what to do. Okay? Now, we already know this as well. If we know the population standard deviation, we can use normal distributions. More often than not, we don't, so we have to use, we have to use the t distributions. In the case of your SAT investigative task, could we find the population mean? Don't they give it to you? Isn't it 503? Right? We are going to treat it with T procedures anyway, okay? This is kind of like a special case just because it's concrete and we can actually do it. More often than not, you won't know it, so you would have to use T anyway, okay? So just kind of keep that in the back of your mind. Yeah. So we're going to just jump in and do an example. So you're going to need a calculator, so make sure you have one. And we're going to look at actually how to do this. So I want you to read this example. I'm going to put attendance in real quick. And I want you to decide, why is this a matched pairs test? Okay? Why is it a t-test? Why are we talking about means? And why is it matched? Yeah. So it's matched by person again, isn't it? Okay? I've got these names. I really don't care who they are. They could be subject 1, subject 2, subject 3. It doesn't really matter. That name doesn't really play a role. It just means that they're matched by person. So this is a before and after design. I've measured their resting heart rate. I put them through this exercise regimen. And now I'm going to do their resting heart rate afterwards just to see if it improved it. Okay? We're looking to reduce resting pulse rates. So that should be a key word, wouldn't you say? Reduce. That's going to help us in a few minutes. So let's start with our first step and do our null and alternative hypotheses. Okay? We know it's matched. We know it's a t-test because why is this means and not proportions? Remember, there's two branches. Why are we down the mean side? Cameron, go ahead. Okay, we don't have independent groups, but we might have independent groups eventually, but that doesn't really mean it's not means. Why is it means and not proportions? What are we given? Are we given the percent of anything, like 25 out of 64, or are we given anything like that? No, we're not dealing with proportions at all. So could we find the average or the mean resting heart rate for this group if we wanted to? Yeah. So that's what we're going to be looking at. Okay. It is a matched pairs t-test. When we're talking about a t-test, what variable do I put in for my null and alternative hypothesis? Mu. So mu is going to be listed. In this case, though, we are actually going to have to, let me write this over here, we're going to have to find the differences. Because I just told you that there are some, and that's what we're going to find is the differences between the two groups. So that's what we're going to calculate here. We're going to add a third column. So when I write my null and alternative hypotheses, I'm going to write them in terms of those differences. Okay? What do you think the differences, what should the null equal? What should the differences equal? If there was no change at all, there was no exercise program, status quo happened, 0, right. So the null is that there's no change, okay? In context, that would be written, the exercise program did not, didn't make a change in the resting heart rate. The differences are the same. Or there is no difference, I guess is a better way to say it. What do you think about the alternative? Okay. Reduce usually means less than. I disagree that it's a less than in this case. Right. So this is a little bit tricky because so often we've been looking for keywords. Reduce is a less than situation, right? So we're thinking it should be less than 0. But the difference should be reduced. So if the difference is reduced, so let's look at some that went down. 83 minus 79, what is that difference? 4. 85 minus 81, what's that difference? It happens to be, those are positive values, don't you agree? So if it does actually go down, which means we have reduced the heart rate, isn't the difference positive? So that's actually our null hypothesis, is that the difference is actually greater than 0. Because the second group did go down. So those differences will become positive numbers. Okay? Any questions about that? Because that's a little tricky. Okay? All right, again, you should be able to write them in context. Let's go ahead and name the test. What is the test? Matched pairs t-test. Good. You should say that. I agree. And then what's next? The conditions. I have an issue with the conditions on this particular example, but there are 3 conditions, so let's talk about them. What's the first one? You want me to write it down? So what would this be? The exercise, does it make a difference? Exercise reduces the heart rate. Okay? What do you think about the conditions? What's the first one? Random sample. Do I see anything about random sample up there? They volunteered. So what are we hoping happens? Think about the design. When we design an experiment, we get the volunteers. Where does the random sampling happen? We randomly do what? Assign them to treatment groups. So we're going to have to assume that, okay? So we can assume that the men were randomly assigned to treatment groups. We can also assume that the sample was representative. Either one is okay. We really should be thinking about, were these men randomly assigned to treatment groups? Were there other treatment groups? I don't know. Was there a control? These are all questions we'd be asking ourselves. What about number 2? It's going to fail the independent condition, isn't it? We know that. They're not independent. So what do we have to do instead? The 10%. So what's the sample size? It's 10. That's a red flag to me as well. But 10 is less than 10% of all men. Okay. Now what? What's the last? Huh? Is it big enough? Nope. Well, so Angelica's thinking on the right track. Can we check to see if it's normally, sort of? Well, maybe. So remember there were 3 groups for large enough, right? What was the smallest one? Less than 15. Isn't that us? If it's less than 15, what do we have to be told? That it's normal. A population's normal. Do I know that? Not really. Okay? So we have to kind of proceed with caution here. I think we could go ahead and plug in the differences and let's graph, just to kind of see and play around with. But we're going to need to proceed with caution because 10 is not large enough. Okay? We just know that. So we should say that. The 10 is not large enough. We're going to proceed with caution. Now, is that ever going to happen on an AP exam? Probably not. Okay? More often than not, they'll probably tell you that the conditions were already met and move on. but I have seen them. There was one we did, didn't we just do a Frappy where you had to write the conditions out? I mean, it happens, right? But I've never seen it where it tells you to proceed with caution and continue on. Let's go ahead and plug them into our calculator. Let's plug in, can we all agree to do it the same way? The first list that's provided to us will be in L1, okay? So the before will be L1, the after will be L2, and then we'll compute those differences. Once you have these lists entered into the calculator, why is it super important not to sort the lists? You remember, because what? Not because of the random thing, but think about it for a minute. First of all, when do we sort? Why would we ever want to sort? Do you remember when we did that? Way back in September, we sorted lists. Why did we do that? If I wanted to find, yeah, not the stem and leaf, the box and whiskers, what you meant, I think, right? To find the median and the quartiles. That's when we would need to do that. It's super important not to sort these, Katie, because they're matched, right? It's kind of like bivariate data in a way, right? So if I sort them, they're no longer matched, and so it's going to become an issue. So just make sure you remember that. We don't want to sort. All right, so over here now, in L3, I want to tell the calculator to find the differences. So that's what we're going to do. We're going to take L1. Remember, look at where my cursor is. It's up on L3, and it's darkened up there. It's highlighted up there. And I'm going to tell it L1 minus L2. And it's going to just kind of populate that and tell me what the differences are. So the differences are 0, 1, 4, 8, 3. And then if I kept scrolling down, it would give me the last remaining ones. We have 2, negative 1, and 3. Not that we couldn't subtract on our own, but there it is. Okay? We are now going to do a t-test, but instead of using list 1, what are we going to use? List 3. So everything we do from here on out will be using list 3, because now I've taken both of these and made one sample from it. We're looking at the sample of the differences. Okay? So let's continue on in that set. What's going to be step 3 in our test? What do we have to do for step 3? The test statistic. The formula for test statistic is a t-value. This is the one for regular t. What do you think I'm going to add to it? The little d's, right? So we're going to look at the mean of the differences, the population parameter of the differences, and the standard error of the differences. Okay? So it's really the only thing that's different. What do you think we're going to need to do? I have to take the mean, and I got to find the mean and standard deviation of those differences. How do I do that on the calculator? Do you remember? How do I find the mean and standard deviation on a calculator? Stat calc. We have to be careful when we go to stat calc. We are doing one-bar stats, but list 3. We're all in list 3 now. So we need to make sure that we're using that third list. There should be nothing in your frequency, so Noelle, take it out, okay? We're just reminding ourselves that we're just doing list 3, and then we'll calculate it. Okay, so I got I'm just going to write this down off to the side. I got that the x bar of my differences is 2.8, and the standard deviation of my differences is what? What number do I use up here? Which one? Yeah, the S one. Again, if you go to IB, those of you who are going to IB next year, you use the other one. Sorry. 2.5298. Probably about where we should stop rounding. We don't want to round too much. All right. Fair enough. Let's plug it in. Let's plug in what we need. I want you to find me the t-score. So I'm going to plug in 2.8. I'm going to plug in 2.5298. What's mu of the differences? 0. Look at our note. Isn't it 0? So we're going to plug in 0 for that guy. What's the sample size? 10. So go ahead and take a second and tell me, what is your test statistic? Tell me what you get. So 3.5 is in fact the t, or the test statistic. We also need to find the p-value. Remind me how to do that. Draw it. What goes in the middle? 0. 3.5 is, sounds kind of unusual if it was a z-score, wouldn't you say? So I'm thinking maybe my p-value should probably be pretty small. Which way am I shading? Even though it said reduce, remember it's the differences, so it is greater than. Okay? So how do I find that value? TCDF. What's the lower bound? 3.5. What's the upper bound? Some big old number off to the right. And then what's the degree of freedom? 9. Double check me, but I think that's the right answer. 0.0033. Is it 3.4? Oh yeah, that should definitely be 3.4. We got a round, right? Okay, good. What now? Conclusion. All right, we're almost done. This isn't bad. What do I do? Linkage. What is alpha? It's not stated, so we'll say 0.05. Which one's bigger? Oh, not 50%. Missing a little 0 there. What do you think? Which one's bigger? The alpha, so it's small. Is that good or bad? It's good, because what can we say? Hi, Felicia, right? See ya. So we can say we reject that sucker. Now, what does that mean in context here? We have evidence, and what does that evidence say? Exercise reduces resting heart rate. So our evidence suggests, we have evidence to suggest that exercise reduces the resting heart rate. Okay, awesome. So really, in a hypothesis test, really, what's the only difference we have to worry about? Well, the condition's a little, well, this condition was weird, but we're really working with the differences. And that's your first step, right? Find the differences. Recognize it's matched, find the differences, and then do everything with that column. Yes, ma'am? In this case, in the differences, yes, it will be. Okay? We're not quite done. We're done with the test part. I agree. We know how to do that. But if you look at the question, it asks us a specific thing. We answer the first one. Is there evidence that this kind of exercise can reduce resting pulse rates? Yes. Wouldn't you agree there is evidence? How much? Does anything we've done here answer that question? How much was it reduced by? No. This has nothing to do with that. All a p-value does is can say yes or no. We can reject or fail to reject. What can answer the question, how much? Katie? Yeah. So we're going to do a confidence interval, okay, for this. What column do we need to use for our confidence interval? For, again, using the difference, okay? So let's refresh our memory. What does that mean, or what does that look like? A confidence interval, let's do a 95% one. The formula is this. When we're talking about the differences, it's the mean of the differences plus or minus t star times the standard error of the differences divided by the square root of the sample size. We know most of that, don't we? I think so. What's x bar? What's x bar? X bar was 2.8. We'll come back to T star. Wow. We'll come back to T. Did it go away? Nice. Okay, let's try again. All right, so we're going to have this. Thank you. So we said 2.8. We'll come back to the T star. What was my sample size again? 10. And then my standard deviation was 2.5298. Okay. How do I find T star? Again, I said 95%. So what goes in the middle for 95? Put in the tail, so there's a 2.5 on either side. I'm going to use inverse T. What's my degree of freedom? 9. So what's the T star? Are there any questions as to why it's 0.975? One of my other students and I were talking. The confidence level that it's asking you and the number that goes in here is never the same. I can say never. I rarely can say the word never, but I'm saying it. Do we have an eaglet? Okay. Sorry, we're watching the DC Eagle Cam. I'm a little addicted. Okay. 95% confidence. This means that 95 is in the middle. We always have to add in one of the tails. So it'll never be the same number. Okay, just keep that in the back of your mind. What is your T star here? 2.26. Right? So we'll plug that in. Tell me what your confidence interval is. What do we get? I'll pause the recording. You tell me. All right. I'll buy that for $1. I agree with that. What does that mean? Before we get into the sentence, what are we looking to capture? 0, right? Is there a difference or not? Is 0 in there? No. It's all above 0. There's not a negative and a positive. 0 is not in that interval. The whole thing is above 0. Wouldn't you agree? So 0 is not in there. We should probably state that, okay? Because it tells the reader what you're looking for. So 0 is not in the interval. Now we'll go with what Angelica started with. We are 95% confident that what? Not the rate at which the heart rate went down, but what are the units in the problem? Goodness gracious, where'd they go? The units were beats per minute, right? So they actually went down this many beats per minute. Okay, it's not a percentage or anything. So we are 95% confident, and they were reduced. I know the numbers are positive, but do we understand why we can still say reduced, right? So we are 95% confident that exercise, or we'll say this exercise, because of whatever the program was, reduced the resting heart rate by between 0.992 and 4.608 beats per minute. So this exercise program didn't capture 0. Our hypothesis test, the p-value was so low, so we actually, both of our information, both of these statistical analysis proved the same, had the same conclusion. Okay, so we're good. And the confidence interval answers the question, by how much? We know by how much it reduced, or at least a range of values by how much it reduced. Okay? If 0 was captured, what could we say? Nothing. We don't know if the exercise program worked or not, because there really was no difference. But here there clearly was. Okay? So let's talk about, first of all, this example cannot be used for your portfolio. Okay? It can't be used for your portfolio because it didn't meet the conditions. Right? The sample wasn't large enough. So you can't use this example. I don't want you to use your SAT example either. What you can use is one of the ones from the textbook that I'm going to assign. Okay? So that's fine. Yes. What number is this one on the portfolio? I believe it is, let me look. Dun, dun, dun. It is number 9 and number 5. It's the dependent data, paired sample. Okay? So you can't use this example, just so you know, but I am going to assign you some textbook problems. Let me write down what those are. There is at least one confidence interval example, and there is one hypothesis test example. You may use these or any others that are in the textbook. And this will be due the Tuesday we get back from spring break. Okay? So the first class. The second part, and this is what I want you to do in class today. Okay? So this is the first thing. So in class today, you're going to work on number 3 of the SAT investigative task. So I'm going to hand this out to you, and let's talk about what that means. And this is where you're going to have to use the sample that you've already taken. Okay? Right? You're about to turn those in. In this assignment, you're going to do problem number 3 only right now. Is there a significant difference between verbal and math scores for these students? Isn't that a matched pairs t-test? Okay? It's matched because it's matched per student. We have a verbal score, we have a math score. You're going to need to use time in class today to look at your sample that you've already collected and come up with a list of the differences. I need you to write those down separately. Does that make sense? Okay, so based on your sample, write down column 3, essentially. Does that make sense? And then once you've done that, you can turn this in. Okay? So that's what I need you to use your sample for. So you're going to be working on the SAT investigative task number 3. Okay? Number 4 talks about, is there a difference between women and or gender, males and females? We don't know about that yet. That's a different test. So we'll do that after spring break. That's why it's due Thursday. Fair enough? Okay. You also, I'm just going to write on here, you should also continue to work on your inference portfolio. That's due on April 8th. So this is due April 8th. Does anybody know when, what the first Tuesday we come back? Isn't that March 28th? Is that right? And then what would the Thursday be? Is it 30 days, 31 days? Yeah. So it would be the 31st. Okay, so it would be due Thursday. Oh, it's the 29th? Thank you. So the 29th, and then that would be April 1st. Right? So just in terms of due dates and what's coming up.